So our goal is to write v equals in terms of t. Right now we have dv dt. So we have to separate the variables and integrate. And I've gone ahead and factored out a -2 because when we divide the v plus 16 over, our integral is going to be easier if there's no coefficient in front of v. So now we can divide that v plus 16 over and get dv over v plus 16 equals -2 times dt. So now when we integrate both sides, we get natural log absolute value of v plus 16, the integral of 1 over, okay, and this equals -2t plus c. So we want to solve for v, so to undo natural log, we have to raise both sides to the power of e. The e and the ln are going to cancel, and that leaves us v plus 16 equals, so what's e to the -2t plus c? That is the same as e to the c times e to the -2t, right? E to the c times e to the -2t. But e to the c is just a constant, so we're just going to write it as a big C, and then e to the -2t. All right? So we know that when v or t is 0, v is -50, so that's going to help us solve for this c. So let's just go ahead and subtract that 16 over first. So we get v equals c e to the -2t minus 16. And then when v is -50, t is 0. So we get -50 equals c e to the 0 minus 16. E to the 0 is just 1. So that means we have -50 equals c minus 16. So then if we add 16 to both sides, we get -34 equals c. So that tells us that v equals -34 e to the -2t minus 16. It's our final v in terms of t. So that's part A. So now it wants us to take a limit as t approaches infinity of -34 e to the -2t minus 16. So we can split this up into its two pieces. We have that piece and we have this piece. This piece is going to approach 0 when t goes to infinity, because we can rewrite it as -34 over e to the positive 2t. And as t goes to infinity, this denominator is going to become massive, which is going to make this approach 0 as t goes to infinity. So then if that approaches 0, -16 is unchanged. That means that we're just going to approach -16 feet per second. And that is our terminal velocity. Okay, so last step was to figure out when our speed equals 20 feet per second. So we're going down at 20 feet per second, so it's -20. And so we're just going to solve for t here. So we add 16 to both sides. We get -4 equals -34 e to the -2t. All right, so we should divide by -34 on both sides. We get -4 over -34 equals e to the -2t. Okay, let's just go ahead and simplify that to positive 2 over 17. Okay, so now we need to solve for t by undoing our e with a natural log. So we get natural log 2 over 7 equals -2t. When we natural log this side, the e cancels, and we're just left with the -2t. And then we can divide by -2, so we get natural log 2 over 7 divided by -2 equals t. And if you type that into a calculator, you should get 1.070 seconds. So that is the time when we reach the speed where it's safe to land.